A lot of high school students struggle with math. It is an intimidating subject for a lot of people, and there are some students who struggle with math who do not want to struggle with math, who want to become good at it. Maybe you're a student who is interested in going into computer science or a related field, and you've always struggled with math and you want to learn how you can become better at it. This video is for you. My name is Josh, and this is Engineering a Better Education. So as I mentioned, today I want to share with you 3 helpful principles that will help you to better understand math and to feel more confident approaching math problems. The first thing I want to say is that anybody can learn math. Just because you've always struggled with it in the past does not mean that you will always struggle with it. And some people have not had great teaching. They've not had math presented to them in a very intuitive way. And so they've been set up in a more difficult situation to understand and love math. But the cool thing is, nowadays we live in the best era there's ever been for education. You can learn anything you want. Knowledge is at the tip of your fingers. And that's because we have the internet, we have AI tools such as ChatGPT that make learning more accessible than it's ever been. So don't feel discouraged if this is you. And I wholeheartedly believe that you can turn into a very successful math student and just a person who loves and uses math in their everyday life well. So the first thing that I want to say is that the best way to learn and understand something deeply is to teach it. So if you are able to teach the thing that you are struggling with in math, then you will be able to understand it well. And if you're not able to teach it, then it means you probably could work on your understanding more. I want to walk through a simple example with you, one that you're probably familiar with. It's a simple algebra example, but let's say you're presented with the equation 2x plus 6 equals x plus 9. So a really simple algebra equation that most people have probably seen, and you've probably been told solve for x. Right? That's the objective that most of us were told to do with this kind of problem. And this is where I want to get into. My first point is, if you can teach something, then you understand it well. If you can teach it well, you understand it well. My second point is, if you can't explain what problem you're trying to solve, then you don't understand the problem well enough to solve it. So let's say you have this equation that I mentioned, 2x plus 6 equals x plus 9. Your goal is to teach this to a 6th grader, clearly, without any jargon, and in a way that the 6th grader will understand it. Let me model for you what bad teaching might look like. Bad teaching is, unfortunately, what some of us have experienced at school before. But bad teaching would be like, all right, we got to solve for x, so let's subtract x from both sides. Then we're going to subtract 6 from both sides, and then we're going to be left with x equals 3. That is an example of a bad way to teach this math problem. And the reason is because we've taught it as a series of steps, not as a way to solve a problem. So too many students approach math like learning a dance, like a dance class or something, where you're learning a choreographed dance and the instructor says, step 1, you do this, step 2, you do this, step 3, you do this. And in a choreographed dance, you would memorize those steps, practice them individually, work on each one. But that is not how math should be taught nor learned. Math is more like solving a jigsaw puzzle, say like a 1,000 piece puzzle. And you wouldn't get good at solving jigsaw puzzles just by watching other people solve puzzles, right? Like you could watch 100 people solve a 1,000 piece jigsaw puzzle and you might get a little better at solving them. But really the way you're going to get better is picking the pieces up and trying to solve the puzzle yourself, taking the pieces in your hand, seeing how they fit together, manipulating them, rotating them. That is a lot more how math is learned and the way that it should be taught. So let me model for you now what good teaching would look like if you were explaining this algebra problem to a 6th grader. You would essentially say, we want to find a number that makes the left side of this equation equal to the right side of the equation. Or you might say something like, there is a secret number that when you double that number and add 6, it's equal to the same thing as taking that number and adding 9. So what could that number be? And this is where you would give somebody the chance to explore. Well, let's try a random number. What about 1? If we double 1 and add 6, then we get 2 plus 6 equals 8. And that would be on the left side of the equation. On the right side of the equation, if we take that unknown number, we're saying it's 1, and we add 9, then we get 10. So that doesn't work out. The sides weren't equal. Let's try 3. If we double 3, we get 6, and we add 6, we get 12, so 12 on the left side. Then if we take 3 and we add 9 to it, we get 12 on the right side. So 12 on the left, 12 on the right. We've now found a solution that if we take the number 3, it makes this equation true. You could even go a step further. You could apply this to a real life situation. Let's say you work at a company where there's a base pay and you earn double that base pay plus a bonus, and your friend earns that base pay plus a larger bonus. What would the base pay need to be in order for you both to make the same amount of money? That's a helpful concrete example of where that algebra equation would be applicable, and hopefully that would make more sense to someone who is learning rather than just solve for X. There's these shirts that I see sometimes, these math shirts where it'll show like an algebra equation. It'll say like find X, and then someone just like circles X and draws an arrow to it and says, I found it. That's kind of what it feels like when we're teaching students to find X. They're not presenting any context with the problem. And so students don't understand why. Like, what does it mean to find X? Why do we want to find X? But when you present it as a bit of a puzzle, almost like a riddle, like what's this unknown number that when you double it and add 6, it's equal to that same number plus 9, then it feels a lot more exciting, a lot more like a puzzle, and a lot more like students could just take this equation and try some things on it. Like, why don't we, half both sides of the equation? Why don't we add this number to it, subtract this number from it, and see what happens? And students can learn that math is about exploring and solving a puzzle more than it is about memorized steps. If the way you've been approaching math is memorizing steps to solving a problem, I'm going to tell you that you're doing it wrong and you're making it more difficult for yourself. Math is not about memorized steps. It's about solving a puzzle and playing with the pieces, manipulating the equations, the geometry, and uncovering truth about numbers and the things those numbers represent. Maybe you've had this conversation before. Maybe you've raised your hand and asked the teacher for help with a math problem. I've heard this conversation before. A student says, I don't get it. And the teacher asks, well, what don't you get? And they say, all of it. I don't get any of it. And what's going on here is that most likely the student doesn't understand what problem they're trying to solve. And if you don't understand what you're even trying to do, then there's no way for you to even attempt to solve the problem, or for you to try different approaches, or for you even to make sense of what's going on. So the most important and the key thing when you're trying to solve a math problem is describe the problem that you're trying to solve. So once again, I had that simple algebra example, but if you could even just write that algebra equation in words and say, we're trying to find a number that when doubled and you add 6 to it, it's equal to that same number plus 9. That would help you understand what you're actually trying to solve, what problem you're trying to solve. And this leads me to want to share with you a special coaching program that I offer for students who are in high school, who are interested in STEM and specifically engineering. I offer a coaching program for them called Design a Product People Want. And the whole idea of this program is to turn students into real engineers without waiting until after college. And the first step that I teach in my coaching program is to identify a problem worth solving, a problem that you're passionate about and that feels important and exciting to you, and getting really clear on that problem. We're not just going to jump in and start building something like you might expect we would do in an engineering program, but you're actually going to hone in on a specific problem that you want to solve, and that's going to add clarity to the whole process and allow you to become a real engineer and design a real product that people actually want, because people want things that solve a real problem or a pain point. So if you're interested in learning more about my coaching program, I've put a link in the description below, and that link in the description will take you to a webpage where you can learn more about it. And if you're interested, you can apply for my coaching program, find out if you're a good fit for it. And going back to the topic at hand, I wanted to share one more example of applying these 3 principles. Once again, the 3 principles are: the best way to understand something is to teach it. That's number 1. Number 2 is, if you can't describe the problem that you're trying to solve, and you can't describe it clearly, then you don't understand enough to solve the problem. And number 3, learning math is more like solving a puzzle than learning a dance. So the second example that I want to share is, let's say there's a math problem where you can imagine rows of dots, and the first row has 1 dot, the second row has 2 dots, the third row has 3 dots, and so on, and it forms a triangle. So you can imagine 1 at the top, 2 in the next row, 3 in the next row. We've probably all seen a triangle composed of dots like this. And the question is, if the triangle is 6 rows tall, how many total dots does it take to make the triangle? So I invite you to try to explain this problem to a 6th grader in a clear way. And once again, a bad example. So I think we could all conclude that the way to solve this, one way to solve this problem is to do 1 plus 2 plus 3 plus 4 plus 5 plus 6. And so a kind of shallow way to explain this problem is, well, we just want to find out what 1 plus 2 plus 3 plus 4 plus 5 plus 6 is equal to. But there's a deeper way to explain this problem and to understand it, and it's that we want to figure out a fast way to count the number of dots in a pattern as the pattern grows. And so it doesn't matter how big the triangle gets, it doesn't matter how big the pattern grows, we want to come up with a method to quickly calculate the number of dots. It's really about finding a way to count a growing pattern. So this is where some students get hung up and they say, when am I ever going to need to know this? When am I ever going to need to count the number of dots in a triangle? And truth is, maybe never. You might not. But when are you going to need to understand how to count a growing pattern? That will come up a lot more, and it's going to look different. It's going to take different forms. So you might not even recognize that it's similar to this problem you learned how to do in school, but if you learn how to count a growing pattern and you understand it intuitively, then when that similar kind of problem shows up in a different context somewhere else in your life, you're going to have the tools and the confidence to be able to solve that problem. So that is really what we're trying to solve here, is a quick way to count a growing pattern. And like I said, one way to solve this problem is just to add up the numbers 1 through 6. Another way you could do it is to realize that if we take that triangle and we copy it, so copy and paste that triangle and flip it upside down, then you can squish all the dots together into a rectangle. And we know that the number of dots in a rectangle would be the height times the width of that rectangle. So if we copy and paste that triangle, flip it upside down, then that first row would have 1 plus 6 dots, right? Because 6 is the bottom row of the upside down triangle, and it's the top row of the right side up triangle. The next row would have 2 plus 5, 3 plus 4, and so on. Every single row is now going to have 7 dots, which is 1 more than the number of rows we started with. And we'll still have 6 rows because when we flip that triangle upside down and stuck them together, the number of rows didn't change. So by multiplying 6 and 7, you would get the number of dots in 2 triangles, which is 42. But since we duplicated the triangles, we now need to divide that number by 2. So 42 divided by 2 is 21. We can conclude that there are 21 dots in that triangle. And the cool thing is we just came up with a method that allows us to quickly count this growing pattern. We could do a triangle with 100 rows in it, and we would know that the number of dots is going to be 100, because that's the number of rows, times 100 plus 1, because we found that when we copied and pasted it and flipped it upside down, it added 1 to each row, n plus 1 dots in each row, where n is the number of rows. And so for a 100 row triangle, you would have 100 times 101 divided by 2. And this is actually a problem that was posed to the famous mathematician Gauss. When he was a kid, somebody told him to add up all the numbers from 1 to 100. And rather than manually doing it by hand, because back in these days they didn't have the kind of calculators we do today that would make this really fast and simple, he noticed a pattern, which was that if he paired 1 with 100, 2 with 99, 3 with 98, that every one of those pairs would equal 101, and that he could multiply that by 50 pairs. So that's just kind of a fun example of how a famous and influential mathematician, Gauss, started thinking like this as a kid and noticing patterns. So I hope that this has gotten you a little more excited about math. I just want to say that math is beautiful. Math is so fun when you understand it. Most students who dislike math, it's because they don't understand it, and it's probably because it hasn't been taught well to them. So if you apply these 3 principles that I've taught today, number 1 is teach it to somebody else. Number 2 is clearly describe the problem you're trying to solve. And number 3 is approach it like a puzzle, not like a memorized dance. So going back to number 1, teach it to somebody else. If you can't teach it clearly to somebody else, it's going to help you identify where the gaps are. If you can't even start teaching it to somebody else, it probably means you don't understand the problem that you're trying to solve. And so that's where you should start. Clearly write out the problem you're trying to solve and make it more intuitive than just solve for X. Because some students, the only problem they know they're trying to solve is they're trying to get an A in math class. And that is not good enough, because it doesn't matter what grade you get in math class. It might seem like it matters now, but that's not going to stay with you your whole life. You're going to reach a point in an age where nobody cares anymore. So the real problem that you're trying to solve is go a level deeper. What am I really trying to learn here? I'm not just trying to learn how to solve for X. I'm trying to learn how to compare two quantities that have an unknown value. Or with that geometry example with the dots, I'm learning how to quantify a growing pattern quickly, no matter how big the pattern gets. So go a level deeper and really describe the problem you're trying to solve. And then number 3, don't memorize a series of steps like you're trying to learn a choreographed dance. It's not step 1, subtract the X from both sides. Step 2, subtract the remaining number from the left side, whatever. It's not that. It's you're solving a puzzle, and there are a lot of ways to solve a puzzle. You might pick up one piece, decide it's not the right fit, put it back down. You might need to rotate a piece. So learn with math that you can just try things out. Like, what happens if I divide both sides of this equation by 2? Does that help me? Does it not? You just explore and you try things. Don't be afraid to fail. Don't be afraid to make mistakes. This is where math becomes fun, is when you feel like you're solving a riddle. Riddles are fun. People like riddles. And that's what math is like. It's like solving a riddle. So those are my 3 tips for you if you're someone who wants to become good at math, but you feel stuck and you feel like you're not understanding it. Apply those 3 principles and know that you can become good at math. You can start enjoying it. And don't be afraid to mess up. Don't be held back by the fear of not getting an A, by the fear of failing your class or getting a bad grade. Those things really don't matter in the long run. What matters is that you are happy and that you're finding enjoyment in learning and growing your education. And that's only going to happen if you let go of that fear of failure. I'm glad that you've watched this video today, and I want to give you a free gift as well. There's a link below in the description that goes to my free PDF workbook called Identify a Problem Worth Solving. And this is, as I mentioned in my coaching program, the first step that I teach to all of my coaching students. I help them identify a problem that they're passionate about solving. And everybody can do this, and this is a good exercise for everyone to go through. So this is my free gift to you. If you click on that link, you'll be able to put your email in, and I will send you the PDF to your email. You can download it and go through it. It's a really awesome workbook. It's very clear, and if you follow all the steps in it, you will identify a problem that you're passionate about solving, which is really cool because that's what being an engineer is solving a problem systematically in a way that other people can benefit from that solution. So thanks again for watching today. I invite you to check out that workbook, and I look forward to chatting with you again soon.